Yeah, students, greetings of the day. This is your Eknath sir, faculty in physics from VIP classes. Today we'll talk about this numerical. Okay, so three boys A, B, and C are situated at the vertices of an equilateral triangle of side length. Okay, some D. Okay, T is equal to 0. So each of the boys move with constant speed V. Okay, so A always moves towards B, B always moves towards C, and C always moves towards A. So when and where they will meet each other. Okay, now if we consider just three particles A, B and C, है ना बच्चों? ये तीन जो पार्टिकल्स है ना, एक दूसरे की तरफ मूव हो रहे हैं. ए हमेशा बी के तरफ डायरेक्शन मूव हो रहा है, बी का डायरेक्शन हमेशा सी के तरफ है, एंड सी का डायरेक्शन हमेशा ए के तरफ है. सो सारे जन वी स्पीड से जा रहे हैं एक दूसरे की तरफ. ठीक है. नाउ से फॉर एग्जांपल अभी देखिए यहाँ. So for example, B moving from this point to this point. Okay. So before line joining AB was like this, isn't it? Now line joining AB will be like this now. Now when A slightly moves here, now line joining C to A, it was before AC. Now it will be new position A dash sum. Okay, like this. Now when B is moving from here to here, A is moving from here to here, and when A moves from here to here, C. Okay, so here C direction will be C right will be when along A, no, so A has moved like this, no, so C will move towards here, so somewhere else here, from here to here, है ना. अभी देखिए जब A B यहाँ से यहाँ गया तो A B की तरफ जा रहा है तो यहाँ से यहाँ आ गया. C हमेशा A के डायरेक्शन में है तो so C will try to move somewhat distance like this, right? When C moves like this, now B always directed towards C, right? Now this is the position of B. Now it will direct towards C like this. So some distance he will come here in this way. When B comes from here to here, okay, A always directed B, right? So A always directed towards B. So you can write now. So A somewhat comes here like this. When C somewhat, so this fellow C will be moving like this. When C is somewhere else, okay, B will be towards him always, right? Somewhat distance like this. And B is coming like this, so A will be always moving towards him, somewhere else here A. And when A is moving, so C will be moving along the direction somewhere else here. When C is moving, so B will like this, and B is like this A. So where they are meeting, all of them, you can see all they are moving at centroid of the triangle. Okay. So now if you see the initial separation along this AB, initial separation along this AB was, okay, some D, and A velocity is like this. So B velocity is always along C, right? So now see, as all of them are moving, A coming like this and B coming like this, okay, so C was like this actually, but so it is going coming and like this meeting. So if you consider initial separation was D, now final separation is 0, so you can say relative displacement is D, right? Now relative velocity along line joining here, okay, so A direction was always like this, so B was in this way, so this angle is 60 degrees. So along line joining, component of B in the direction of what? A. So this is V, right? So this will be V cos 60. Now along AB if we consider, velocity of B along AB is V cos 60 and A is V, and they are coming and moving like this and they are meeting at this point centroid, right? Separation becoming 0. So the relative velocity along line joining will be how much now? So both are in opposite. So velocity of, for example, if you take velocity with respect to B, so you can say VA minus VB. So VA is V minus of, so B का component इसके डायरेक्शन में कितना है? So V cos 60 but opposite में है, so इसलिए minus V cos 60. It becomes V plus V by 2. This becomes how much beta? This becomes 3V by 2. So both the particles are moving and are meeting at the centroid. So just find their velocities along line joining. Okay, so relative velocity, so you can time taken to meet them, so they are meeting at centroid, and time taken to meet them is what? Distance by here V relative, distance by V relative, how much here? So that is V plus V by 2, which is equal to 3V by 2. So this becomes now time taken to move them is equal to 2d by 3v. Okay, so this is the time. So actually after which they are meeting. Okay, so like this you have to approach for the problem relative velocity of approach. Okay, when separation is decreasing we call them as velocity of approach, when increasing we call velocity of separation. Fine. Yeah, please. Thank you all.